It may not be the prettiest thing in the world, but it works, and I drew it myself. Hello, I'm Wade Gibbs. I'm here at my home office in Seattle, and today for this Spectrum hands-on feature, I will be making conductive ink. I'm going to be mixing the metals indium and gallium to make an alloy that is liquid at room temperature, which I'll then place into this pen and use to draw circuits. I will be following a method that was published recently by Professor Jing Liu and his students Yi Zheng and Qin Zhang of the Technical Institute for Physics and Chemistry at the Chinese Academy of Sciences in Beijing. All of the materials used in this project were purchased relatively inexpensively from a popular online shopping website. So, let's get started. Let's start with some of the materials that we'll need. A rollerball pen with a refillable cartridge, about 30 grams of indium, 99.9% pure, about 100 grams of gallium, also 99.9% pure, a Pyrex glass beaker, this one is 400 milliliters, but 1/2 the size will work as well, a glass stirring rod, a plastic syringe with a tapered tip. I'll use this for inserting the alloy into the pen cartridge, a sharp-pointed scratch awl, which I'll use to make holes into which I'll place resistors and other components, deionized water, which prevents the metals from oxidizing while we form the alloy. We'll also use transparencies of the kind used for inkjet or laser printers. The trickiest part of this project is getting the regular ink sitting in the cartridges out. My first thought was to bleed the pen dry. I placed the pen onto a folded paper towel, tipped down, and let it sit overnight. Sure enough, the ink wicked away into the towel. I drilled a hole through the metal base of the cartridge. Then I confirmed that it was empty. Next, I heated water on a hot plate to 50 degrees Celsius and placed the gallium into the hot water until it melted. I weighed out the indium and dumped it into the deionized water. Then I weighed out the gallium. And added it to the flask with the indium and the deionized water. I used a glass stirring rod to stir the two metals together for 30 seconds. The deionized water serves as a buffer to keep the metals from oxidizing. They form an alloy quickly. I used a tapered tip syringe to suck up the liquid metal ink. A little bit of water came into the syringe, but inverting the syringe allowed me to press the water out of the top. The water beads up immediately on paper because of its high surface tension. I injected the liquid metal ink into the empty pen cartridge, but I found to my dismay that the ink quickly escaped through the air holes in the bottom of the pen cartridge. So I tried a different kind of cartridge. But as soon as the cartridge was full, ink started dripping out the air holes at the bottom. Finally, I found a brand of rollerball pen that uses a cartridge that has no air holes in it. It's a very simple design. The end of the cartridge is plugged up with a little bit of glue or liquid plastic. I used a drill bit to remove this. Then I used a syringe filled with denatured alcohol to flush out the ink, repeatedly squirting alcohol in, emptying the syringe, and then sucking the ink and alcohol out. It was messy business. But finally, the cartridge was very clean, and I could see the ball rolling around freely inside of it. I injected the empty cartridge with the liquid metal ink. It was very messy, and I was glad to be wearing eye protection and gloves for this part. But at last I had a cartridge that was ready to use, and I tried it on the smooth side of a transparency. It was quite a relief when it started writing smoothly. The liquid metal ink adheres quite nicely to the smooth transparency material. I broke out the multimeter to check whether these ink traces were actually conductive. Sure enough, they were. With the pen cartridge now working, it was time to draw some circuits. I printed my circuit pattern onto a transparency and mounted it onto a self-adhesive foam board. I had used the awl to pre-punch holes where component leads would go. Next, I used the awl to perforate the foam board through the holes I had made earlier. And then I dry mounted all of the components to make sure that the hole spacing was correct and that everything fit nice and snugly. With all the components dry mounted, it looked like everything would fit fine, so I removed them and used my specially equipped pen to start drawing the circuit traces with conductive ink. Many of the lines required me to go over them several times to get a nice, consistent, complete line without any gaps. Once the traces were all drawn, it was time to mount the components. I put them in carefully so as not to smear the ink around. Once the components were mounted, I used the pen to fill in around the leads just to make sure that the leads made clean connections to the wires. and then I use the multimeter to do some quick continuity tests. At last, it was time to give it a whirl. So there you have it. It may not be the prettiest thing in the world, but it works, and I drew it myself.